Now we will verify different types of numbers whether they satisfy given properties with respect to addition and multiplication. First, we will verify with respect to addition. If these types of numbers satisfy different types of properties with respect to addition, we should write yes. If it is not satisfied, we should write no. Here, first, rational numbers. Rational numbers satisfy closure property with respect to addition. So, here he mentioned yes. Now, is rational number satisfy commutative property with respect to addition? Yes. A plus B equal to B plus A. If we add two rational numbers in any order, we will get the same result. Here, yes. Now, associative property also, yes. Existence of identity. We know additive identity is 0. Is 0 exist in rational numbers? Yes. So, we should write yes. Now, existence of inverse. For any rational number, additive inverse exists. So we can write rational numbers satisfy existence of inverse. If you take 2 by 3, what is the additive inverse of 2 by 3? For 2 by 3, by what we should add to get 0? Minus 2 by 3. Minus 2 by 3 is there in rational numbers. Minus 2 by 3 is the additive inverse of 2 by 3. 2 by 3 is the additive inverse of minus 2 by 3. Both exist in rational numbers. So, a rational number satisfy additive inverse. Now, next, integers. Is integers satisfy commutative property? Yes. Is they satisfy associative? Yes. Now, existence of identity. Additive identity 0 existed in integers. So we should write yes. Now existence of inverse. For integers, if you take minus 7, by what we should add to get 0? Plus 7. And this 7 existed in integer. Plus 7 minus 7 both existed in integer. So integers. Existence of inverse is there. So integers satisfy inverse property with respect to addition. Now whole number. Is whole numbers closer? Yes. If you add any two whole numbers, the result is also whole number. So we can write yes. Commutative property. If we add any two whole numbers, we will get the same result if we change the order also. So we can write here yes. Now associative is also yes. Now existence of identity. 0 is existed in whole numbers. So yes. Existence of inverse. Now in whole numbers, if you take 3, by what we should add to get 0? Minus 3. But minus 3 is not there in whole numbers. That is why here he mentioned no. Whole numbers won't satisfy additive inverse. Now natural numbers. Is natural numbers satisfy commutative property? Yes. Any natural number, two natural numbers, if you add, the result is same as you change the order. That's why you can write here yes. Associative property is also yes. Now existence of identity. We know that additive identity is 0. Is 0 is in natural numbers? No. 0 is not existed in natural numbers. That is why we should write. In the same way, existence of inverse. For any natural number, if you take the additive inverse, we will get negative number. That negative numbers are not in natural numbers. That is why here, no. So, in this way, we should complete the now. With respect to multiplication, we will verify whether these numbers satisfy the given properties. Now, rational numbers. Here, rational numbers satisfy closure property with respect to multiplication. So, yes. Commutative property also they satisfy. So we should write yes. Associative property also they satisfy. Now existence of identity. We know multiplicative identity is 1. So if you take any rational number, 2 by 3. Now 2 by 3 into how much will give you 2 by 3? 1. Is 1 existed in rational numbers? Yes. So here we should write yes. Existence of inverse. Now if you take for any rational number, multiplicative inverse is there, but for 0, there is no multiplicative inverse. In rational numbers, multiplicative inverse is not existed. So we should write here no. Now integers. Is integers are closer with respect to multiplication? Yes. Any two integers, if you multiply, will get the integer only. Commutative property, yes. Associative also, yes. Now, existence of identity. Is 1 existed in integers? Yes. Now, existence of inverse. If you take any integer means if you take 0, 0 is integer. For this, is multiplicative inverse existed? No. So, we should write here. Next, whole numbers. Is whole numbers closer? Yes. Any two whole numbers, if you multiply, you'll get the whole number only. Next, commutative. This is also yes. Associative also yes. Now, existence of identity. One is multiplicative identity. Is one there in whole numbers? Yes. So you can write here yes. Next, existence of inverse is not there. So you can write no. Why? Because for 0, there is no multiplicative inverse. That is why we should write here natural numbers. Is natural numbers closer with respect to multiplication? Yes. If you multiply any two natural numbers, you will get the natural numbers only. Now, commutative. Yes. Now, associative. This is also yes. Now, existence of identity. Is 1 existed in natural numbers? Yes. Now, inverse. This is no. In this way, we filled all these types of numbers, whether they satisfy these properties with respect to addition and multiplication. Okay.